the junction of the vast Atlantic and Indian Oceans, there is a high mountain with a truncated top in Cape Town, South Africa. It is known as God's Table for its magnificent shape, which is the world famous Table Mountain. When you look across the bay at the skyline behind the central Cape Town, Table Mountain's regular and graphic table-like silhouette is so striking that many people can't help but wonder, lost in wild and fanciful thoughts. Wow, indeed, this can only be the masterwork of God. But in the eyes of geologists, the very flat, regular shape of Table Mountain is nothing more than a product of coincidence in earth-changing history. Well, the world is full of such coincidence. In the Big Bang of the universe about 4.6 billion years ago, a solar system happened to appear. During the formation of the solar system, there happened to be an Earth. It just so happened that in the history of the Earth evolution, at the southernmost tip of Africa, there appeared a table mountain like God's table. All this was the result of a series of coincidences in geological events. Yes, the mountains, rivers, and lands we see today, as well as many peculiar and wonderful geological and geographical landscapes, are all the results of coincidence during various intermingling and complex events of the universe. When you carefully observe the topographic map of southern Africa, it is not difficult to find that to the south of a large area of mountains and plateaus, along the coastal lowlands at the Cape of Good Hope, the southern end of Africa, there is a mountain system extending from east to west, which is like a scarf wrapped around the southern end of Africa. Because they look quite different from the northern mountains and plateaus, it is indeed an extra gift of nature to African continent. That is the well-known Cape Fold Belt, which is quite a product by coincidence in geological events that took place here several billions of years ago. Unfolding the geological map of southern Africa, the Cape Fold Belt will be displayed before your eyes much sharper. To find out how it was formed, you have to date back about 1.1 billion years. At that time, there was only one supercontinent called Rodinia. It's a patchwork made up of many ancient land blocks that gave birth to the most primitive land mass of all 7 continents today. Then, about 700 million years ago, driven by the Earth plate movement, Rodinia Pangaea began to break up. By a very strange coincidence, the rift where Rodinia Pangaea split just lies between today's Southern Africa and South America. Here the Pangaea split up and created a huge rift valley. Water, pours in along the Rift Valley, forming a vast ocean called the Agulhas Sea. The ocean is the ultimate destination of all the rock products that were withered and denuded. During eons of geological years, the sediment produced by withering was deposited and piled in the Agulhas Sea, forming thousands of meters thick sedimentary rock stratum, which records the changing history of the surging sea. By a very strange coincidence, this thick sedimentary rock stratum today unexpectedly forms the majestic massif and cliffs of Cape Town's Table Mountain, namely the stratum geologically known as the Table Mountain Group. The Table Mountain Group is composed of two parts. The upper part is the hard Table Mountain sandstone, and the lower part is the Graft Water Formation, which is formed by intertidal zone, coastal plain, and multiple transgression deposits. The Table Mountain Group records the history of the changing Agulhas Sea. Not coincidentally, the stratum of exactly the same age and lithology as the Table Mountain sandstone in Cape Town has now been found in Argentina, which is far away from Africa, since the Agulhas Sea then also extended into South America. This fully supports the inference about the formation and evolution of the Agulhas Sea. But how did the sedimentary rock stratum in the ocean turn into today's Table Mountain? This is another story full of coincidence. Being together for too long a time will end up divided, and apart too long, merged. In the Devonian Carboniferous period 300 to 400 million years ago, the Earth's fragmented land masses began to slowly coalesce again and gradually formed a supercontinental block called Pangaea. It consists of two ancient continents, North and South. To the north was Lower Asia, encompassing present Eurasia, Greenland, and North America. The southern part includes present Africa, South America, India, Antarctica, and so on. It was called Gondwana. The formation of Pangaea supercontinent, especially Gondwana, led to the gradual closure of the Agulhas Sea, southern Africa. Under the intense pressure of the Gondwana merging, the sedimentary stratum in the Agulhas Sea was further squeezed and pushed, creating a violent uplift much like the Himalayas today. Eventually, by so strange a coincidence of geological events, in the Permian period around 290 million years ago, the sedimentary stratum of the closed Agulhas Sea off the southernmost tip of Africa was squeezed and folded into a huge parallel mountain system, and that is how the Cape Fold Belt was formed. Geologists often noticed that when the originally flat rock stratum is squeezed horizontally, a series of concave and convex arches will be formed. That is, anticline and syncline structures. A series of syncline and anticlines often form mountain systems that extend in certain direction within the region. The structures of anticline and synclines can sometimes be seen clearly in the field under certain conditions. But in many other cases, it is relatively difficult to distinguish. One would think that a high mountain must be formed by an upward arching anticline, while a valley by a downward bending syncline. But geologists warn people look at mountains and rivers historically. After anticlines and synclines are formed, they will undergo the destruction of long-term geological processes, especially withering and denudation. The peaks and valleys we see today are topographically just opposite to the up-arched anticline and downward bending syncline in the common concept. There is a special chapter in geology textbook explaining how synclinal mountains and anticlinal valleys are formed. This may seem unusual, but it's quite easy to understand considering the direction of force exerted on the anticline and syncline rocks at the time of fold formation. People might ask, aren't fold belts made up of rock strata that twist and bend? But the rock strata that make up the Table Mountain are basically horizontal. So, what does the Table Mountain have anything to do with the Cape Fold Belt? First of all, we have to be certain that the Table Mountain is indeed part of the Cape Fold Belt. But how can there be parallel formations in a fold belt? Here, it is necessary to point out that the lack of geological thinking will adversely limit one's imagination. It should be explained first. The so-called geological thinking means that in the study of geology, either time or space is based on a wide range beyond the ordinary people's imagination. In geology, time is measured in millions or tens of millions or even hundreds of millions of years, while space is often measured in tens or hundreds of kilometers. Therefore, you can imagine that in a folded mountain system stretching hundreds or even thousands of kilometers, it is inevitable to have a small section of horizontal rock formation. Here, a small section, in terms of geological thinking, could be an area of dozens or even hundreds of kilometers. Table Mountain in Cape Town lies by coincidence within this small section of horizontal rock formation. Viewing Table Mountain in Cape Town from the perspective of geological thinking, we cannot ignore the withering that has taken place on the Earth for hundreds of millions of years. Withering and denudation are sculptors of the Earth's topography. It flattens mountains and fills rivers and oceans with withered rock debris. It competes with the orogenic movement of the Earth, and its ultimate goal is to continuously create planation surface. Orogeny and withering are a pair of eternal contradictions in the development and history of the Earth. People often praise and marvel at the towering and majestic mountains on the Earth, but sometimes ignore the magic created by weathering and denudation in the transformation of the terrain. Because what weathering and denudation produce is subtraction, while what people see is the residual results of the mountains weathered and denuded. Therefore, it is up to the geologist to reconstruct the landscapes before weathering and denudation, and to show how powerful weathering can be. The diagrammatic sketch of Table Mountain after weathering and denudation drawn by geologists reveals what remains of the once towering Cape Fold Belt stretching for hundreds of kilometers is the lonely Table Mountain that now still stands upright there after the impact from the Earth's sculpture weathering. It seems as if the Table Mountain is left here for geologists as evidence to prove that there was once a vanished Cape Fold Belt. Meanwhile, it also makes a clear note on why the rock strata of Table Mountain in Cape Town show horizontal distribution. Table Mountain is just the only evidence that hundreds of kilometers of Cape Fold Belt was by coincidence preserved. Because it lies at the core of the syncline, the rock stratum also by coincidence retain a roughly horizontal extension direction. How wonderful nature is, and how wise are the geologists who can go so far as to rely on a lonely upright Table Mountain to connect the various coincidental events in hundreds of millions of years geological change history in the southern tip of Africa, and reconstruct the history and to return the truth of the Earth's evolution. Geologists have given us a real sense that Table Mountain in Cape Town, South Africa, is a miraculous product of a series of coincidences in the history of the Earth's evolution. Our Earth is full of such miracles.